So, hi everyone, my name is David. I'm a cloud engineer at Dynatrace. So, besides building platforms and dealing with deployments and running of tools, basically, I love everything regarding mountains and mountaineering, which is legally obligated because I'm from Salzburg originally, and also making music, going to concerts, and everything related to that. So it's super cool to be back at this meetup because a few years ago I had my first talk at exactly this meetup here in Linz, and so it's great to be back. So where could I possibly start with my topic today? And obviously, I need to start with Godzilla, obviously, right? So why, you may wonder, do I need to go with Godzilla first? So some time ago, I watched a video from a science communicator called Hank Green on his channel, where he invites a pretty diverse array of different guests who he then talks with about pretty random stuff. So there is really nothing off limits. It's from microbiology to how far homing pigeons can fly, basically one vlog podcast thing. And so on this episode, he invited a comedian and they started talking off script, basically, about how big they could make animals on Earth. So in physical terms, basically, what is the structure and in which environment could they grow an animal to a certain size? And so they discussed stuff like elements, dinosaurs, and in the end, that was not good enough. They landed on Godzilla. So how big could they make Godzilla if they had the means to do so? And so they discussed questions like, could they somehow change gravity? Could they change up some bones with carbon bones? Things you usually discuss when you talk with friends, right? And what could do the trick? Or in other terms, so to say, what components do Hank and David need to change off this huge monster to make it even bigger? Yeah, what components do they need to tweak to do that? And as an operator, this of course immediately reminded me of a tool called Argo CD. And so basically I just stole that concept a bit of this video to look at different components and kind of see what we can do to make it an even bigger monster than it is already a lot of times, so to say. So that brings me in the end to the title of my talk, Monster-Sized GitOps, How to Scale Argo CD. But to take a quick step back, just to read the room a bit. So who here knows about Argo CD or has ever seen it, knows it conceptually? Nice. Who has actually done something with it? Who has deployed 10 apps with it? So you can now just leave your hand up and I will go progressively further. 100. How about 1,000? Okay, little meager there. How about 10,000? This is then just to see if people are still engaged with my questioning, but all right. So quite some people know what's up. So I will really fast go over this just to really take everyone with us. A very small introduction to GitOps and Argo CD. So what problem does this tool actually solve? So imagine you have a Kubernetes cluster, and over the time where it's deployed and doing things, people talk to it, give it manifests, give it workloads, either via kubectl directly. They might apply a Helm chart. They might also have a bash script or something else somewhere that does something to the cluster. But in the end, when you look at it a year later, you wonder, okay, what is actually the state of that thing? Where is all this coming from? What purpose does it serve? What should the state be like of this cluster? So in the end, what is the single source of truth there? Yeah? What should actually be on there? And this is a concept called GitOps. Kind of solves how basically you have everything that should run on the cluster as code in some repository as a configuration. And so the question is now, how do you implement this pattern? And this is what Argo CD can do for you. So you have it as a tooling in between your configuration and the cluster, and you give it then a resource called application, where you tell it, hey, please take this configuration, apply it there. This is how it looks like in general. I will go deeper in that later on. Yeah, and everything, all the configuration that I show here will be also be available at some point later. So just some facts that people who have never heard about it see. This project is kind of huge in the open source community, in the Kubernetes community. So just some key facts. Pretty battle hardened. A lot of companies use it. Yeah. So of course, this is not what I want to talk about today, because this is what I want to talk about today. We are scaling that thing to an even bigger monster. And so you might ask yourself rightly, why do I even want to do this? Yeah, scale Argo CD so far. So first of all, there is, depending on the problem that you want to solve, multiple solutions and architectures how you can set up Argo CD. Can one big one centrally, many small ones shared. There is also an agent architecture now, not related to AI, by the way. And different use cases have different requirements and different solutions based on what you're trying to achieve with your GitOps setup. Nevertheless, it's an interesting experiment, even if you're using a different architecture, and some of the problems that I'm going into, you will have at any scale. And obviously also because I can, yeah. Experimenting is fun. So that's why let's take a look at the monster. Yeah? The first thing we need to do is, like I said before, the components of the monster. If we want to understand what bends and breaks and what we need to tweak, we need to understand what's actually in there. So let's start with the thing the monster is standing on, which is the world, which is Argo CD and its resources. So it's literally the platform our monster lives on and is built on, and it provides the Kube API and the resources we need for it to run. Quite fast. So that's just the surroundings, so to say. Yeah? Then, what is the brain of our monster? The brain of our monster is called the application controller. So it's the centerpiece kind of Argo CD. It coordinates everything else. So these applications that determine what configuration goes where, it reconciles it and then makes it into reality. Yeah? So it continuously compares the desired state of your configuration to the live cluster and applies it. Via a sync. So again, this is how this resource looks like. Pretty straightforward. It's an application you apply it to your cluster as a Kubernetes object. This is where you point it to your config, say, hey, please take this and deploy it to my destination server here. So quite straightforward in how it rolls out stuff. Going on, what are the jaws of the beast? The jaws of the beast is the repo server. Yeah? This is the component, or the insatiable maw that devours information from Git. It's the component that fetches the repositories so that actually then Argo CD can apply it to the target cluster. So it renders the manifests that we have, could be Helm, customized, plain, YAML, anything. And then it prepares the desired state for comparison and to sync it up. We have the stomach. The stomach is our application set controller, so it's the second Kubernetes operator in our mix in here. It digests many random things at once and can influence the brain directly. So it's a bit of a biological deep cut, yeah. It's a Kubernetes controller, as I said, that reconciles kind application set. And it's basically there to create a ton of those applications that I already showed you automatically from a folder structure or something else. So this is how it looks like. In this case, we point it to a folder structure and tell it, hey, please go ahead and from each folder in here, create me an application with this template. So basically rolling out your applications at once without like creating every single one by hand. Yeah. Then we have the spines. The spines is our Redis. It absorbs and stores for further usage. Yeah? It's a key and value in memory data store and cache that is used by Argo CD for caching and coordination to improve performance, because it has to deal with a lot of data, and so it just caches it. Yeah? This is not really our focus today. You have to scale it like a regular Redis, make it HBA like a Redis in a high availability environment, but it's a Redis. It's not very specific to Argo CD, the problems. And in the end, we have the atomic breath. It's the server with the UI. It delivers all the digested information right back at you, sometimes a little too much. Yeah, and this is what users and automations talk to for login, viewing apps, triggering syncs. So in the end, the important question is, how does it all come together? How does the flow actually look like? For this, of course, a bit of a simplified view, otherwise it would not go on one slide. But yeah. So we start by rolling out one application set. So this application set contains basically the instructions for our folder structure that we then want Argo CD to know about and roll out to a cluster. So our application set controller sees this, says, okay, nice applications I recognize, and creates the applications. From there, our application controller reconciles them and asks the repo server, hey, I have a bunch of manifests I should actually roll out. Can you please fetch them? Which then the repo server does, pushes it in the Redis, and gives it back to the application controller, who then can say, okay, nice, now I go to my target cluster, roll it out. Great. Then we have the user, and the user can then ask the server, can you please provide me this information? And the server then also asks the Redis, hey, please give me that information. Yeah, and if you have a workflow that needs to digest this also somehow, there is REST APIs they can talk to. So this is practically how it works. And in the end, when you're the user, this is what will pop up. So basically then your application that you get from the REST API, you will see here in this view that anyone who has ever used Argo CD probably knows. All right. But let's deploy something. That's why we're here. We want to not only look at it, but also break it. And of course, step by step, we also want to try to avoid our specimen's untimely demise, because we want to actually grow it and not kill it. So let's start very fresh with a small little fresh install from the Helm chart, just nothing, 10, and put 10 apps on it. So again, so this is our setup now. Again, application set controller sees it, creates our applications, application set controller sees them. Repo server fetches our manifests, puts it in our cache. Stuff gets deployed, our user asks the server, gets back the response. Everything green. Great, right? Well, not really. We have 10 apps and it's a simple install. So, I mean, super lightweight scenario. In the end, we get back, okay, so everything green, but we want to do more than this, right? This was just a default install. Some general things, though, we can already talk about is you have to feed your monster well when you want it to grow, and observe and add resources as you kind of have to. So feeding the monster keeps it healthy, and there are no real recommendations by Argo CD going forward how to do this. It's very there are a few defaults in the Helm chart. There are a few defaults for like sample setups, but nothing specific where they say, hey, do this, do that. You kind of have to observe and figure it out. Yeah? And the use cases can be quite different, as we will see very soon. Generally, the places and configs we need to adjust for anything we do is the workload resources ourselves, so the deployments, the replica sets, and the relevant config maps. These are very important, that have a ton of different options, which is usually the Argo CD config map, the big one, or the params config map. So just to prepare, you will see them a few times in the oncoming experiment, so to say. So this is how these look like, basically. Different deployment, different stateful set where you can just go ahead, override resources, and so on. So we could now do the same thing with 100, but that's still a bit boring. So let's go and do 1,000 at once in our fresh install. So it's still our toddler version of Argo CD, and now we just put 1,000 apps on it and see what happens. All right, so application set. Application set controller sees it, starts running. We have to wait a bit. We wait a bit more. We keep waiting. Okay, this is not working out already. Okay, why? Okay, how does our application set controller scale? Generally, this is a controller that has one instance, and it's only this one instance. More additional replicas are just acting as failovers, okay? So that means the more it needs to do, the bigger this one instance needs to be. So this thing needs to be big. And also the concurrent reconciliation limit, we need to up that thing because it can still limit how much it can do at the same time. Basically, it just has a hard limit, hey, just 2 things at once. And so give it resources, tell it to do more at the same time. So we can do this. This is an example, for instance, from the params config map where we can do stuff like this. And yeah, give it more resources, make it bigger, let it actually do the work. Another thing that will get worse over time, this thing operates with something called generators. So this is the fancy thing you saw in the application set example before, which says how do you even go ahead and create these applications in the first place. So this thing can be heavily optimized. A good example would be here. Here you see, okay, it goes into that one folder, makes an application out of everything in that folder. But what happens if we start doing this? Suddenly we have a nesting of 2 layers, or 3 layers, depending on how we configure it. And it needs to do much more just with very small tweaks. And suddenly nothing works anymore and this whole thing goes up in flames. So we need to be careful on how to configure this, and there's huge potentials to optimize this depending on how complex our setup is. Okay, cool. So it works again. Let's assume. Let's go. It creates our applications and the application controller sees that, starts running, and you might already feel it getting warmer in the room, because this one is burning down completely. So how is this, why is this working? How does this one scale? Okay, the application controller can actually have multiple replicas, even though it's a controller, because they are pinned directly to clusters. So one cluster is always pinned to one port, to one replica port of our application controller. This means we can have a setup like this. And if we want multiple replicas with multiple clusters, we need a setup like this. So it's not possible to say, okay, one cluster goes to 2 replicas. That's not how it works. Behind the scenes, it's one cluster to one replica. So it would scale up in this way. And here, why did it burn down? It went completely out of resources. So here we need to tell it, hey, more replicas when there are more clusters in the future, so that Argo CD knows how to pin stuff with this environment variable, and give it more resources so that it will actually survive the thing as well. All right. Also important, we need to take a deeper look at what we are deploying in the application, because it could be smooth like this, so small application, free resources, get back after a short time, okay. But we could also do something like this to our system, because there can be any number of resources deployed within this one thing. And so maybe sometime later you might get an okay or a timeout or whatever. So it's important to take a look on how we use these resources and not just how many we have. Okay, we stabilized it. Let's go. The repo server gets called, do that thing for us, asks our repository. Hopefully this turns out well. Well, it also goes up in flames. Why is that? So I already told you how it generally works. Yeah, so it pulls it from Git, pushes it in the cache. And this one we can horizontally scale also, because it's not a controller simply. And yeah, so what we can do here is simply do that. So we give it more replicas, we give it more resources. There's also, of course, optimization potential similar to our application. It very much depends on the artifacts that you roll out with this, because it could be here raw manifest, which is just like take the file, apply it, but it could render a super complicated Helm chart as well, which takes obviously a lot more resources. So your artifact here might mean a lot more work in some use cases, And a tip here, you can also go ahead and pre-render your manifest. This also saves you some computing power here. Yeah, so you can also up the parallelism limit similarly to the last one. It's a very nice word to pronounce as well, can recommend. Also a pointer to any tool, but this one in particular, updated. They solved a pretty nasty Helm rendering bug with version 3.0, which makes the monster happy that it's solved. And should people tell to update their tools whenever there is good new features out and whenever possible. Okay, so finally, push it into Redis. That works out. And then we can roll it out onto our cluster. Great. Our user can also now via the server get this information. Is very happy. And then the user says, wait a second, I want to do another commit because I forgot something. And the user does this commit into our monorepo that keeps all the 1,000 apps. And everything goes down in flames again. So why did this happen? Well, it was just one commit, but basically our whole system keeps retriggering everything when there's a commit on the repo. So this is fine when you have a structure like this, where you have one repository, one project, where everything regarding the project is in a folder. But once you go monorepo, this is very bad because it tries to reconcile everything on every single commit. But you can tell Argo CD to actually only reconcile an application once a specific path changes, and this is something that you should definitely use. Yeah. End of sentence, basically. And it's also very, very easy to actually add this as an annotation to application resource. Yeah. And you can, by the way, you can also tell it to use webhooks, which means it will not poll your repo all the time, but actually do only something when the webhook gets called. And fresh from the press, it can now, since the last minor version, also do shallow clone, which means you need to pull a lot less data at once and not all the history all the time, which is kind of shocking that this came out just a month ago and not like 10 years ago. Okay, maybe not 10 years ago, but a longer time ago, yeah. And give the server also more resources just as an add-on, but the server actually performs still well because it needs to do relatively little compared to the other resources, yeah. Okay, so it's time to grow up. Let's feed all of this to our monster. And now let's see how it behaves with this scale up. So now we have a graduated version, so to say, yeah. So we go again through our flow. Everything gets called and applied. And actually, and this is the important part, we also do a second commit, yeah? And everything works out. Great. So this is green, but still boring. 1,000 applications is for starters. Now we go ahead and we apply 10,000 applications. So into our graduated version now. And let's not bore you with the flow again, yeah, because everything burns down. But why does it burn down this time? That's the more interesting question. And so, yeah, by the way, our server is still working fine. So the user just doesn't get any useful information back, but so it's now time to really grow up. And this means, of course, first of all, again, give it a lot more resources, scale it higher up, give it more replicas. We are dealing now with a lot of clusters, so this means we need to pin them to more replicas so that they keep surviving. And we also need to look at other stuff. For instance, hey, what Kubernetes is this running on? Does it have enough resources? Can the Kube API itself actually keep up with what we want to do here? Yeah? Because pulling thousands of objects from the same API at the same time might actually lead to throttling or even timeouts on the API level of your Kubernetes cluster itself. So depending on where it's hosted, these need to be addressed differently, of course, these issues. But in general, the cluster needs to keep up with what we want to do here. Another very sneaky optimization that we need to do is on the pinning level of the replicas. So I showed you this picture before, but not the complete picture, because of course, any of these clusters that are pinned here can have a vastly different amount of apps depending on what we run there. Yeah? So this cluster could, or this replica could have to reconcile 100 apps that run on these 3 clusters, and this one 1,000 apps that run on these clusters. Yeah. So this is really bad because they all basically have the same resources, and some have to do a lot more. Well, there are features to do all this sharding, is what this process is called. So you're handling these replicas are called shards. Doing it in a smarter way with different mechanisms. The bad thing is they're all still in alpha since a long time. So if you actually want to run Argo CD on your production environment, it's discouraged, of course, to use alpha features. But what can you do actually? So this makes the monster pretty mad also. So what can you actually do? And the sad truth is manually reshuffling it. So basically go ahead, look at your clusters, look at your shards, and in your cluster secret that defines where Argo CD needs to go, or basically gives it also points it to the right cluster credentials and everything, you can tell it, hey, please use shard index, whatever, wherever you want it. So you can go ahead and manually tweak it until it's kind of balanced. So this is really right now the only way with a not alpha feature to accomplish this, which is kind of sad, but sometimes necessary to do this because otherwise you will definitely kill some shards while others idle away. Yeah. Then at this scale, responses generally can get very long, and if it's not properly configured, things can run a timeout, can lead to like follow-up issues in different components. So we need to somehow address this, and there's a ton of different configurations we can tweak. So from like tweaking how long reconciliations are allowed to take, to excluding some resources as to not even reconcile them in the first place, to go ahead and defining here timeouts for a ton of different things, especially within these reconciliation loops on the applications. It's very important to find kind of a balance in how often do you want to reconcile them, to give the system time time to do what it needs to do with the resources that it has. So I highly encourage taking a closer look into these params configuration maps, param configuration maps, and the Argo CD configuration map, because it's very reliant on actually, as I told you before, how the cluster is set up, how the applications are set up, and everything in between. You really need to kind of tweak it to what you deploy with it. But this is the biggest pointer. Like there is a ton of different timeouts that can be configured in there. And some are still sneakily hidden inside actually deployments themselves. Yeah, some things like the Argo CD execution timeout you can only configure as an environment variable in the deployment itself. So they are slowly trying to get everything in there, but some of it still isn't. So maybe there is still some hidden flag that you did not uncover yet, in case you're tackling a problem like this. And this brings me to a very, very important point. The point before already led a bit. Observe it very, very actively. Use the metrics that it emits, and it emits actually a ton of metrics, and ingest them in the form that you need, that you want. You can tweak the log level for every single component here, ingest it, see how it actually behaves at runtime to tweak these configs that I showed you in a way to get the system running stably for you and for your setup. So with this very tweaked environment, let's go and deploy the 10,000 apps. So this is the final form of our monster. And yeah, so application set controller creates applications, getting reconciled, repo server fetches, pushes in the cache, stuff gets deployed, and the user still gets its answer. So things are working out. At this level of scale, we can already see some things do not go very, very much further from here if we want to use all the components. Stuff like the application set controller, because of its nature, that it's just this one pod. Even if we it has, for instance, a limit how much concurrent things you can do. So for some of the resources, you hit basically a hard set barrier at some point where you need, if you want to go actually further than this and not use a different architecture, you need to think about how can I deal with or without these components as a whole, try to get like different approaches to solving these things. And also, very interestingly, it does not have server-side pagination. So whenever you actually open this dashboard, it loads all the applications at once, which is extremely annoying still. There are a ton of issues open since a long time, so that they somehow have server-side pagination and not do this. But yeah, that means sometimes you need to wait 10 seconds until they actually pop up on your dashboard. Yeah, but other than this, system works. And so this brings me to the end. So what are the gotchas? Feed your monster well. I hoped I got that out very, very clearly. Be aware of those passkey shards and other scaling mechanisms. Really, sometimes you need to look closely to the components. Fine-tune the reconciliations and timeouts of these Kubernetes objects. And think about your setup as much as you think about Argo CD. It's super important. And definitely observe everything you do, see how the components behave, see how they behave with different amounts of work, with different artifacts that you apply, and so on and so forth. And with these tricks, you can create a monster as well. Yeah, and small addendum, if you want to chat about this afterwards. So did I skip maybe the attributes of your favorite component? Reach out. Was the origin to component mapping correct? I struggled a lot with this. What component, in your opinion, actually deserves to be the colon? You can freely talk, say your opinion, yeah. Yeah, and a few important resources. We'll share the slides. I will also hopefully finish the repo where all these resources are in and can share it. And with this, thank you for your attention.
Questions? So you said about 1,000 applications is a realistic limit.
No, not really. So it depends. It depends very much on what you deploy. I mean, in the end, I went with a very extreme scenario. So high amount of rendering effort, and so depending on what you apply. So let's say you only apply like raw manifests, and you can also use, for instance, patterns that do not use the application set controller, but something called app of apps, where you apply these application resources directly, so that you basically get rid of the component that scales the least, so to say. You can go very far, I would say. But it really depends on the applications and how you package them very much.
Okay, there's not a general number you can say, but it depends on the size and complexity.
Yeah, it really does. I try to give like a few general pointers on how things scale, but in the end, it super depends on how you package and ship your single packages of applications, so to say. Yeah.
And from there on, you get a new cluster.
When you reach the hard limit?
Totally separated, I would say, with another Argo CD complete instance.
When you run into it not scaling anymore?
Yeah,
or?
exactly.
There are multiple patterns. Yeah, you can try to, and it really depends on like I said, how you deploy things. You could go with multiple Argo CD instances as well, but of course then the maintenance is doubled and tripled depending on what you do. Yeah? Because of course you need to maintain the different instances then as what they are, different instances. Yeah.
You should understand that there is only deploy, and all those 10,000 of applications are totally unusable. You cannot do even, I guess, HTTP requests to any of them. It will not answer. Because you just deployed the application and that's it. The cluster is full.
when you say application, do you mean a workload or an application as an Argo CD object?
Okay, a pod and a service in terms of Kubernetes, for example. If you deploy 10,000 pods to one Kubernetes cluster, you can create such number of, for example, if you can create such number of instances, such number of objects in the cluster, the Kubernetes API will accept it, but that will not work.
I mean, it depends. I mean, generally it depends how many nodes you have, I guess. But you can plug a ton of different clusters to one Argo CD instance. That's the thing. So you could have 100 clusters behind one Argo CD instance and pick inside the application which application goes where. So it's not like bottlenecked on the number of clusters you can connect to the system.
Yeah, I understand that it is discussable. My question is, what is the amount of the resources did the monster at the end eat? I mean, how much how much of the resources do you need to give your monster to live in the cluster?
So based on, let's go a bit back. Okay, actually probably here will be easier. Yeah. So by the way, I will package these neatly into one repository and share.
Okay.
Here I have a few good pointers, basically, based on different workloads, what I observed in different scenarios that works. But it's very important, like I said before, to understand that depending on how you deploy your workloads, this might highly differ. So there is not this value where you say, okay, at 10,000 it will demand 5 gigabytes of RAM. It doesn't work like that. It really depends on the real work that the components need to do to go from I fetch it from an artifact registry to I get the rendered manifest to the target cluster. And depending how easy or hard this pipeline is, it needs more or less compute to achieve it.
Yeah, I see, but it's 20 replicas with 5 gigabytes is 100 gigabytes in total.
Yeah, it needs to do a ton of work.
Okay.
Of course, it's an extreme example. That was kind of the purpose. Yeah, that was kind of the idea.
Yeah, okay. Yeah, that's it.
I'm not saying that it's cheap.
Money is not the problem.
Especially if you don't optimize and such stuff. Yeah.
And David, I guess I know you didn't say it, but the number 10,000 just didn't come out of your imagination, because there are companies that run Argo at that scale successfully.
Yes, I guess there are.
Yeah. So
everyone can guess now who we're talking about.
Yeah. So that's why, right? I mean, this is not theoretical. To your point, right? It really works, and it's great that you are showing and sharing all of the things we've learned as we scaled our internal Argo deployment at Dynatrace, right? So to that size. For me, the interesting question is, if you go back to let's go back to slide 98. We have the architectural overview with all of the burning flames. I think another key interesting thing is that there's a lot of interaction between the repo server and Git, which means that's potentially also a challenge with API rate limits. And obviously you need to make sure that this is not getting...
Yeah, basically, and in the end, it's like, it's just a microservice architecture. So, and this is yet just another service that the service calls. There is actually hidden inside, I think here, I had one. Repo server git request timeout. Because this is exactly also a big problem. And this problem grows bigger when you're having big monorepos, because this is also why I was such a fan that they finally did shallow clone. because then it's much easier to get monorepos with a lot of changes in a more efficient way into the system. Yeah.
And I also thought it was interesting that he brought up the Kubernetes API being a potential bottleneck. And then I'm wondering if there might be a smarter way of querying the current state, maybe keeping next to the Redis that keeps kind of like the desired state, maybe keeping also the active state based on a different mechanism, not just polling the Kubernetes API all the time. I'm not sure if Argo is working on anything like this, right? Like thinking about like keeping your current state by just seeing the changes that are happening.
Let's go back to visualize it. Yeah, here, I mean, with the server, really the problem is that they load all the data at once. So that's the problem with the server, that it's just they're loading such big data blobs, it wouldn't even matter where they come from. And it's rather, yeah. I mean, in the end, really the application controllers need to reconcile the real objects at some point. And there, with the reconciliation limits and the timeouts and everything, you kind of need to find a balance on how to do it effectively, because you cannot afford kind of to get much drift in there. So yeah, at some point they need to reconcile the real thing, and if it's 10,000, then they need to do the work, so to say, and the API needs to deliver them.
I just thought, so you used a generator technically to generate 10,000 of the applications which have the same structure, right?
Yes, or let's say the applications have the same structure.
Yeah.
So
I mean the manifests.
Yeah.
Why then repo server got overloaded? Why did the repo server tried to each 10,000 times to get that application from the repo, but not just from cache from Redis?
There are different components that could also theoretically talk to different systems. Like the application set resource is completely unrelated basically to the applications. For instance, it just means it rolls out applications. The applications themselves could point to an entirely different repository, for instance. True. Exactly. So this is why there's no real way to use this mechanism like this. Yeah. They're like completely decoupled processes.
I mean, from what I understand, Dynatrace is kind of doing the same. Like you deploy a huge amount of the environments which are pretty much the same, and kind of those applications. So do you benefit from cache in your production environments or not? I mean, the cache that in Redis, or you also get the same issues, like getting the code once and the second time 10,000 times from the repo server again and again, or it's not so?
Are you asking about now the caching in Argo CD?
Yeah, sure. Because we are talking now about Argo CD.
Okay, no, I was just trying to understand that. It's using it's using Redis. Yeah, it's using the cache. So the answer is yes. This is the default mechanism on how a lot of things get faster inside the system, because they can be taken from the cache and don't need to be refetched and re-rendered all the time. Mm-hmm. So yes, definitely. Especially also with when you actually want to show it over the dashboard or over the API, it would be pretty brutal to like go through the whole reconciliation to fetch them then from the source repo to get it through the pipeline. You need to save it somewhere.
Yeah, sure.
Yeah.
Sure. Yeah, I have a question. Maybe it's not related to Argo, but did you try other solutions than Argo? I mean, something else.
You mean like Flux or something?
Crow. Did you try Crow? Kubernetes Runtime Orchestrator. It's a new thing by AWS.
I mean, Crow solves a different issue. Crow solves a different thing, though. I mean, it's.
Yeah, you can create definition of your own
You
custom
mean
runtime
to
resource.
create applications, or?
Yeah, for sure. You can define an application. You can define custom API in terms of Kubernetes, and define your application in terms of API without need to develop an operator, because here are two operators working on two operators, and Crow is an operator itself, and you can deploy that your custom runtime definitions to deploy applications as well. What you need.
I mean, these. We can also continue
Yeah,
generally
I guess
chatting
it's-
about
yeah.
cloud native tooling around it.
Yeah, sure.
I mean, in the end, maybe it's the last sentence. I mean, these are the components of Argo CD itself. If you would try to replace them with something else, I guess then that's just a different thing entirely.
Yeah, sure.
Yeah.
That's pretty much discussable. Again, yeah.
Yep. Thank you very much.
Thanks. Yeah.